Dear students, today we are continue the problems of limits. Right? See, question number 11. Limit x tending to 0, logarithm of 1 plus x cube divided by sine cube x. What is the formula related to logarithm? The formula related to logarithm is limit x tending to 0, limit x tending to 0, logarithm of 1 plus x, logarithm of 1 plus x divided by x, logarithm of 1 plus x divided by x is equal to 1. This is the formula related to the logarithm. Right? Now, how to calculate the limit value of the given function? Right? That is equal to limit x tending to 0, limit x tending to 0, logarithm of 1 plus x cube. Here, divide numerator and denominator by x cube. Divide numerator and denominator by x cube. Sine cube x divided by x cube. Now, applying the above formula, limit y tending to 0, logarithm of 1 plus y divided by y, that is equal to 1. In denominator also, limit x tending to 0, sine cube x divided by x cube, that is also equal to 1. So that 1 by 1, that is equal to 1. That is the limit value of the given problem. Right? Now, see question number 12. Compute or calculate limit x tending to 0, x tan 2x minus 2x tan x divided by 1 minus cos 2x whole square. Right? See this, how to calculate this limit value. If we substitute the limit value, the given function is of the form 0 by 0, that is indeterminate form. Right? How to calculate the limit value of this function? Right? That is equal to limit x tending to 0, limit x tending to 0, x into tan 2x. What is the formula for the tan 2x? Tan 2x is 2 tan x divided by 2 tan x divided by 1 minus tan square x, 2 tan x by 1 minus tan square x minus 2x tan x minus 2x tan x divided by 1 minus cos 2x. 1 minus cos 2x, that is 2 sin square x, 2 sin square x whole square. Right? That is equal to limit x tending to 0, limit x tending to 0. See the numerator, 2x tan x is common. Take 2x tan x as common in the numerator, 2x into tan x. Take 2x into tan x as common in the numerator. Now we have 1 by 1 minus tan square x, 1 by 1 minus tan square x minus 1 divided by 2 square. 2 square is 4, sin square x whole square, that is sin power 4x. Right? That is equal to, here 2 1s, 2 2s are gets cancelled, 1 by 2 is a constant. So, write 1 by 2, limit x tending to 0, limit x tending to 0, x into tan x, x into tan x, take LCM, 1 minus 1 plus tan square x divided by 1 minus tan square x divided by 1 minus tan square x whole divided by sine power 4x whole divided by sine power 4x. Right here 1 gets cancelled, that is equal to 1 by 2 into limit x tending to 0, 1 by 2 into limit x tending to 0, x into tan cube x into tan cube x divided by sine cube x, sine power 4x into limit x tending to 0, 1 by 1 minus tan square x, 1 by 1 minus tan square x. Right, observe this function, right, divide numerator and denominator by x power 4, divide numerator and denominator by x power 4, that is equal to 1 by 2 into limit x tending to 0, x into tan cube x tan cube x divided by x power 4 divided by sine power 4x divided by sine power 4x divided by x power 4 into, by applying the limit to this function, that is equal to 1. Right, here x gets cancelled. Now this is x cube, tan cube x by x cube is equal to 1. Similarly, sin x whole power 4 divided by x power 4, that is also equal to 1, so that the required limit value, that is equal to 1 by 2. Right. Now this is exercise 8b. Find the right hand and left hand limits of the function at the point a is equal to 1. Right, how to find the left hand limit and right hand limit of the given function at the given point. Right, now left hand limit simply can be written as LHL. LHL is called left hand limit. Right, limit x tending to here a is equal to 1, x tending to 1 minus limit x tending to 1 minus f of x, that is the left hand limit at x is equal to 1. Limit x tending to 1 minus means that x less than 1. X tending to 1 minus means x less than 1. What is the corresponding function when x less than 1? That is 1 minus x is a corresponding function when x less than 1. Now here no need to write x tending to 1 minus, simply limit x tending to 1. Now by applying the limit value, that is equal to 0, left hand limit is equal to 0. Now right hand limit, simply RHL, right hand limit, that is RHL limit x tending to 1 plus limit x tending to 1 plus f of x, that is equal to limit x tending to 1 plus x tending to 1 plus, it means that x greater than 1. If x greater than 1, what is f of x? If x greater than 1, f of x is equal to 1 plus x. In this also, no need to write x tending to 1 plus, simply write x tending to 1. Right, by applying the limit value, we get the limit value is equal to 2. Right, see what is the value of LHL and RHL? Those two are equal or not? If those two limits are equal, then the function has limit exists at x is equal to 1, otherwise limit does not exist. Therefore, limit x tending to 1 minus f of x is not equal to limit x tending to 1 plus limit x tending to 1 plus f of x. Therefore, limit x tending to 1 f of x does not exist. Limit x tending to 1 f of x does not exist. Right, since left hand limit not equal to right hand limit. Right, now see another one. This is second Roman question number 1. Okay, here f of x defined a piecewise function. If x less than 0, the corresponding image is 1. If x lie between 0 to 1, the corresponding image is 2x plus 1. If x greater than 1, the corresponding function is 3x. Right, here also verify the limit exists or not at a is equal to 1. Right, now consider left hand limit x tending to, here also 1 x tending to 1 minus f of x, that is equal to limit x tending to 1 minus x tending to 1 minus means x less than 1. X less than 1, the corresponding function is 2x plus 1. Right, so here x tending to 1, by applying the limit value, that is equal to 3. Now right hand limit limit x tending to 1 plus limit x tending to 1 plus f of x is equal to limit x tending to 1. Okay, x tending to 1 plus x tending to 1 plus means x greater than 1. X greater than 1, the corresponding function is 3x. The corresponding function is 3x. Now by applying the limit value, that is also is equal to 3. Therefore, limit extending to 1 minus f of x, limit extending to 1 minus f of x is equal to limit x tending to 1 plus f of x. Therefore, limit extending to 1 f of x, limit extending to 1 f of x exists and is equal to 3. Limit extending to 1 f of x exists and is equal to 3. Right, this is the way to find the left hand limit and right hand limit of a given piecewise function. Right, now let us see next problem. Question number 3. Show that limit x tending to 2 minus modulus of x minus 2 by x minus 2 is equal to minus 1. Here x tending to 2 minus, x tending to 2 minus, that implies x less than 2. X tending to 2 minus, it means that x less than 2. That implies x minus 2 less than 0. X minus 2 less than 0. If x minus 2 less than 0, that implies modulus of x minus 2, modulus of x minus 2, by the definition of modulus of x minus 2 is equal to minus of x minus 2, since x minus 2 less than 0. Right, now limit x tending to 2 minus or x minus 2 tends to 0, x minus 2 tends to 0, modulus of x minus 2, modulus of x minus 2 is equal to minus of x minus 2. minus of x minus 2 divided by x minus 2, x minus 2, x minus 2 gets cancelled, that is equal to minus 1. That is the limit value. Right. Now let us see question number 4. Here x tending to 0 plus x tending to 0 plus, it indicates that x greater than 0. X tending to 0 plus, it means that x greater than 0. If x greater than 0, that implies mod x is equal to x. If x greater than 0, then mod x is equal to x. Now the limit value, limit x tending to 0, limit x tending to 0, 2 into x divided by x, 2 into x divided by x plus 1 plus x plus 1. Right here x gets cancelled. Now by applying the limit value, we get 2 plus 0 plus 1, that is equal to 3. Right, that is the limit value. Right, now see this limit. Compute limit x tending to 2 plus, limit x tending to 2 plus box x plus x, box x plus x. How to find the limit value? Okay, here given that x tending to 2 plus, x tending to 2 plus, it means that x lie between 2 and 3. It means that x lie between 2 and 3. That implies box x is equal to 2. Box x is equal to 2. That is equal to limit x tending to 2, limit x tending to 2, box x is equal to 2, 2 plus x. Now by applying the limit 2 plus 2, 2 plus 2, that is equal to 4. Right. Now also find limit extending to 2 minus, limit extending to 2 minus box x minus x, limit extending to 2 minus box x minus x. Right. Okay, limit extending to 2 minus box x minus x. Okay, right, this is plus x, this is plus x. Right, as x tending to 2 minus, x tending to 2 minus, so x less than 2, x less than 2 and greater than 1, so that box x is equal to 1, box x is equal to 1. Right, that is equal to limit x tending to 2, limit x tending to 2, 1 plus x. Now by applying the limit, that is equal to 1 plus 2, that is equal to 3. Right, this is the right hand limit and this is the left hand limit. Here right hand limit not equal to left hand limit, right hand limit not equal to left hand limit. Therefore limit x tending to 2, box x plus x does not exist. Limit x tending to 2, box x plus x does not exist. Let us see next one. Define f mapping from closed interval minus 1 by 2 comma infinity to real number set defined by f of x is equal to square root of 1 plus 2x, where x belong to closed interval minus 1 by 2 comma infinity. Then compute right hand limit at x is equal to minus 1 by 2 of f of x. Hence find limit extending to minus 1 by 2 f of x. Right, see the problem very carefully. This is a different problem. Okay, this is different from previous problems. See, what is the domain of this function? What is the domain of this function? Minus 1 by 2 comma infinity. This is the domain of the function. So, at x is equal to minus 1 by 2, only right hand limit exists. Only right hand limit will be defined. Okay, right. Left hand limit not defined in this domain. The domain is minus 1 by 2 comma infinity. At x equal to minus 1 by 2, only right hand limit will be defined. Right. Okay. Here compute limit x tending to minus 1 by 2 plus f of x. Right. As x tending to minus 1 by 2 plus x tending to minus 1 by 2 plus, it means that x greater than minus 1 by 2. It means that x greater than minus 1 by 2. That implies 2x greater than minus 1. That implies 2x plus 1 greater than 0. That implies, it means that 2x plus 1 tending to 0 plus 2x plus 1 tending to 0 plus. Right. Now, the given limit can be changed to limit 2x plus 1 tending to 0 plus limit 2x plus 1 tending to 0 plus square root of 2x plus 1 by applying the limit value. Right hand limit at x equal to minus 1 by 2 is equal to 0. Hence, find limit extending to minus 1 by 2 f of x. Actually, we have to find left hand limit and right hand limit at x is equal to minus 1 by 2. But here, consider the domain, only right hand limit exists at x equal to minus 1 by 2. The right hand limit at x equal to minus 1 by 2 is equal to 0. Hence, limit x tending to minus 1 by 2, limit extending to minus 1 by 2, f of x is equal to limit x tending to minus 1 by 2 plus limit extending to minus 1 by 2 plus f of x. Right? Okay. That is equal to the right hand limit at x equal to minus 1 by 2 is 0. Right? So that the limit is equal to 0. Okay. Right. This is the limit value at x is equal to minus 1 by 2.